In today's class, let me introduce two important terms. One is average velocity, another one is average speed. Average velocity, average speed. So you all know motion is nothing but change in position with respect to time. When body moves, its position changes with time. But how fast is the position changing with time and in what direction? So this is a natural question. To describe this, we are going to introduce you the term average velocity. This will explain how fast is the position changing with time and in what direction. Let me concentrate on average speed few minutes later. First, let me discuss about average velocity. As the body moves, its position changes with time. You all know. How fast is the position changing with time and in what direction? To describe this, we define or we introduce this term average velocity. This will explain you in what direction the position of the object changes, okay, and how fast the position changes with time. The average velocity is denoted by the letter V bar. The bar over the quantity represents the average quantity. Here V is velocity, V bar is average velocity. It is defined as the ratio of displacement over the time interval. Imagine a body is at x1, that is the initial position of the body is x1 at t1 initially. Let x2 be the position of the same body after certain time t2. At t1, let x1 be the position of the body. Let x2 be the position of the body at a later instant t2. We all know that this is treated as initial position. This will be treated as, no doubt, the final position. What is delta x? Delta x is displacement. That is nothing but final position minus initial position. This displacement will be taken place in the interval delta t equal to t2 minus t1. Interval length is delta t, which is equal to t2 minus t1. Therefore, the average velocity V bar equal to x2 minus x1 divided by t2 minus t1. This is how we define average velocity. Average velocity is defined as, or is nothing but, the displacement or the change in position divided by the time interval in which the displacement occurs. Average velocity is nothing but the displacement or the change in position divided by the time interval in which the displacement occurs. x2 minus x1 divided by t2 minus t1. What is x2 minus x1? This is displacement, no doubt, which will be in meter. Correct. So 5 meter minus 2 meter. So it will be 3 meter. t2 minus t1, 5 second minus 3 second, that will be 2 second. Therefore, this will be in second. So SI unit of average velocity would be meter per second, that is ms per minus 1. This is the SI unit of SI unit of average velocity, meter per second, even though kilometer per hour is used in our everyday calculation. Okay, most of the cases we often use kilometer per hour as the unit of average velocity, but that is not the SI unit. SI unit is meter per second. Conventionally, as a larger unit, we practically go for kilometer per hour. Kilometer per hour. Okay, it's a larger unit. SI unit is meter per second. Fine. All right. Okay, in the previous class, we considered a situation. We have plotted xt graph. I guess you all remember. A body starts from rest, from the origin, moves along a straight line. It picks up its speed till 10 seconds, and after 10 seconds till 20 seconds it moves with average, it moves with uniform velocity, and brakes are applied, and it eventually stops after traveling a distance of 300 meter at the end of 22 seconds. Okay. So let me write the position time graph. Let me consider only till 10 seconds. It picks up its speed. Okay. Let me take the position time graph. Okay. Position x in meter along the y axis and the corresponding time along the x axis. You all know position time graph will come like this. Okay. So 2, 4, 6, 8, 10. Okay. 2, 4, 6, 8, 10 seconds. Okay. So this is position. Okay. 5 meter, 10 meter, 15 meter, 20 meter, 25 meter, 30 meter, and so on. Okay. So this is the position time graph where the body starts from rest, from the origin, and till 10 seconds, okay, imagine till 10 seconds it picks up its speed. Correct? Okay. Now if you want the average velocity, okay, between t equal to 4 second to t equal to 9 second, if you want the average velocity between this interval, that is 4 second to 9 second, no doubt this is t1, this is t2, correct? T1 is 4, t2 is 9. Okay. Corresponding position, this will be x1, and okay, imagine this will be x2. Okay, x1 is less than 5, say 4 meter, imagine. x2 is less than 15, say this is 13 meter, just considering. Okay. Therefore, average velocity over this interval 4 second to 9 second would be x2 minus x1 divided by t2 minus t1. Correct? x2 minus x1 divided by t2 minus t1. x2 is how much? Say 13 meter minus x1 is 4 meter divided by t2 is 9. Okay, t1 is 4. Okay, so this is 13 minus 4. Okay, 9 divided by 9 minus 4. Correct? 9 minus 4. Okay, this is this much meter per second. This is the average speed v bar over the interval t equal to 4 second to t equal to 9 second. This is how we can calculate average velocity using xt graph. But actually, this is the initial point. Let me call it as P1. This is the final point, final position P2. You join the initial point P1 to the final point by a straight line. This is a straight line. P1, P2 is a straight line joining initial and final positions of the body under motion or in motion. The slope of the straight line joining the initial and the final position P1, P2 would give you the average velocity v bar. Graphically, if you take the slope of the straight line joining the initial and the final position, that is nothing but the slope of the straight line joining the initial and the final position will give you the value of average velocity over that interval. That is one important feature of a position time graph. Slope of the position time graph, slope of the xt graph represents velocity. Here, slope of the straight line P1, P2 gives you the average velocity v bar over the interval V bar over the interval considered. Okay, V bar over the interval t equal to 4 seconds to t equal to 9 seconds. Okay, over this interval, if you calculate the slope of the straight line P1, P2 joining the initial and the final position. Okay, so that is indeed the value of average velocity what we have calculated like this. Okay, so you will get the same answer if you calculate the slope of the straight line joining initial and the final position, that is slope of the straight line P1, P2 gives you the average velocity over the considered time interval. Okay. So this is how actually we calculate average velocity using xt graph. Okay, all right. Now you all know that average velocity is defined using displacement. You all know displacement is a vector quantity. No doubt average velocity is a vector quantity which is both magnitude and direction. But in this chapter, first chapter, we are not going to use vector notation even for vectors. We use plus and minus signs for directional aspect. You know, in one dimensional motion there are only two possible directions. Okay, we will be giving plus sign for one direction, say forward direction, so minus sign for backward direction. So directional aspect will be taken care by plus and minus s. Therefore delta x is a vector quantity, nothing to do with time, time is a scalar. Okay, V bar average velocity will be a vector and which carries the same direction as that of displacement. So displacement can be 0, displacement can be positive, displacement can be negative. You all know. Similarly, we have defined average velocity using displacement. No doubt average velocity over an interval can be positive, can be 0, as well can be negative. We can draw the position time graph for positive velocity, negative velocity and zero velocity. Okay, three cases I can write: positive velocity, negative velocity, zero velocity. Okay, one by one. Position time graph, you all know, x in meter, t in seconds. Okay, this is first one, positive velocity. Slope of the position time graph represents velocity, keeping that in your minds. Okay, so positive velocity means you must draw a straight line with the positive slope. Positive slope like this. It can be okay like this. It can start from here or anywhere. Okay, so like this. It's a straight line with the positive slope for this. Okay, positive slope. This one over. Next, negative velocity, position time graph. Okay, x in meter, t in seconds. Okay, negative velocity. Negative velocity. So again, the straight line must have negative slope like this. Okay, this is a straight line with the negative slope. Okay, it's a straight line. Okay. Straight line with negative slope. This representing a body having negative velocity. A body having zero velocity. Position time graph, x in meter, time in second. Okay, zero velocity. The slope of the straight line must be 0. Zero velocity means body is not moving. It has no velocity. Body is at rest. Okay, you are all familiar with this. Okay, the position is fixed, only time is changing. Okay, the body is at rest or body has zero velocity. The slope of the straight line is 0. This is xt graph representing positive velocity. This is xt graph representing negative velocity. This is a xt graph representing zero velocity. Okay, to know the rate of motion of an object along the actual path, we are going to define another term that is called as average speed. You all know magnitude of displacement may or may not be equal to the distance traveled. Keeping that in your mind, to know the rate of motion along the actual path, we are going to introduce you another term, that is average speed. It is defined as average speed. Average speed is defined as the ratio of the path length or the total distance traveled to the total time taken. Average speed is nothing but path length divided by the time interval length or time taken. And path length, no doubt, it will be measured in meter. Time taken will be measured in seconds. So SI unit is same as that of average velocity, same unit, meter per second. But please note, average speed is defined using path length. Path length is being a scalar which has only magnitude. Path length can never be negative. Path length is always positive, it is a scalar, it has only magnitude. Okay. So keeping that in your mind, average speed is also a scalar quantity which is always positive. Okay. Average speed carries the same unit as that of average velocity. But keeping this in your mind, average speed is a scalar quantity which has only magnitude with no specified direction. This average speed will tell you the rate at which the position of the object is changing with time, but it is not specifying the direction. In what direction the position of the object is changing is not obtained in average speed. Average speed only tells you at what rate the position of the object is changing with respect to time on the actual path. But in what direction, okay, this term is not going to answer because it is a scalar, it has only magnitude. That is the basic difference. It is defined using path length. Path length is a scalar. Any of you know time is a scalar. Average speed equal to a scalar, okay, which has the same unit as that of average velocity, meter per second. And average velocity can be 0, can be negative, can be positive, but average speed is always positive. This is one important distinction. Okay. And in general, you all know path length is more or sometimes equal to the displacement. In general, path length will be more. Because if the body changes, the actual path length will be greater compared to the displacement. If the object is not changing its direction, it is maintaining a constant direction, its body is moving in the same direction, then average speed and magnitude of average velocity will be same. If the direction changes, then average speed will be different and average velocity, magnitude of average velocity will be different. This can be observed through a simple example. The magnitude of average velocity may or may not be equal to average speed. This can be seen through a very simple example. We have consider the motion of the car from O to P, okay, along the positive x-axis, imagine, okay, like this. First class we discussed, let this be the origin, okay, origin at t equal to 0, x equal to 0. This is positive side, positive x-axis, okay, positive x-axis. Okay, this is 50 meter, this is 100 meter, 150, 200, 250, 300, 350, 400, 450 meter. So this is x in meter. Okay, this is you all know negative x-axis. Yeah, this is the origin reference point. Okay, as you go rightwards of O, position is taken as positive. Okay, as you go leftwards of O, position is taken as negative. Correct? As you go rightwards of O, position is taken as positive. As you go leftwards of a reference point O, position will be taken as negative. This will be minus 50, this will be minus 100. Fine. So consider the simple example. Car is moving from O to P. Let it be point P. Okay, car is moving from O to P in this direction. Okay. And car returns to Q. First case, car is moving from O to P. Second case, car is moving from O to P and returns back to Q. Two situations. Okay, two different situations. First situation, car moves from O to P. Okay. For this, in this situation, let us calculate both average velocity and average speed. Average velocity. Okay, average velocity in the first case. Okay, first case, average velocity. We all know that delta x over delta time, that is displacement over time taken or interval length. Fine. Displacement. Car is moving from O to P. Initial position O, that is position is 0 meter. The position of P is, you all know, point P is from the right of O at a 400 meter away, that is plus 400 meter. So this is x2, this will be x1, correct? Therefore delta x equal to x2 minus x1, you all know. Therefore delta x equal to x2 plus 400 minus x1, that is 0, plus 400 minus 0 divided by time, say time. So car takes 20 seconds, okay, 20 seconds for the motion from O to P. Okay, so that is 20 minus 0, because initially 0. After 20 seconds, the body or the car will be at P. Therefore, plus 400 divided by 20, 2 ones are 2 twos are, that is plus 20 meter per second. What is this? This is average velocity of the car or of any body when it moves from O to P. Okay. So it has both magnitude and direction. Magnitude is 20 meter per second and direction, yes, direction is positive, means it is moving in the positive x direction. Fine. For the same situation, let us calculate average speed. Average speed equal to, you all know, definition, path length divided by time interval. Okay, path length divided by time interval, that is average speed equal to path length. Path length is body is moving from O to P, that is OP is path length divided by time interval. It has taken 20 seconds. OP is how much? OP is 400 meter, right? O to P, the distance from O to P, that is 400 meter divided by 20. 2 ones are 2 twos are, okay, that is 20 meter per second is the average speed. Average speed is 20 meter per second. Average velocity is plus 20 meter per second. Here, when a body moves from O to P, the magnitude of average velocity is 20 meter per second, which is exactly equal to the average speed. Again, this is not the case always. In this case, both are equal. Magnitude of average velocity and average speed are equal. Yes, let us see what happens in this case. Body moves from O to P and returns back to Q. Okay, definition same. Second one, body moves from O to P and returns back to Q. Fine. So here initial position is O. This is intermediate position, not needed. This is final position Q. Okay, this is final position. Final position. Q is final position. What is the position of Q? Where is Q? Q is plus 150 meter right of O. That is 150 meter right of O. That is plus 150 meter. Position of Q is plus 150 meter. Fine. This is 0 meter origin. Okay. Yes. Now I can write average velocity V bar equal to delta x, x2 minus x1 divided by t2 minus t1. Correct. Therefore, V bar equal to, what is x2? x2 is position, final position of Q. That is plus 150 minus x1. x1 is 0 divided by, so both will be in meter, okay, and divided by t2 minus t1. Okay, t2 minus t1, that is the total time. Imagine car takes 20 seconds, okay, from O to P, and from P to Q it takes, imagine, 5 seconds. Okay, car moves from O to P in 20 seconds and returns back to Q in 5 seconds. Therefore, the total time will be that is time taken here, total time taken will be 20 seconds plus 5 seconds, that is 25 seconds for the whole journey. Car moves from O to P in 20 seconds and returns back to Q in 5 seconds. For the total for the whole journey, the total time would be 25 seconds. Therefore, plus 150 divided by meter divided by 25 seconds. Correct? 25 ones are how much? Plus 25 fours are 100, 25 6 are 156 plus 6 meter per second is average velocity V bar over or during the course of motion. In the second case, that is car moves from O to P and back to Q, that is plus 6 meter per second. Magnitude of average velocity is 6 meter per second and the direction is in the positive x direction or the forward direction. Yes, for the same situation, let us calculate the average speed. Average speed is path length over time interval. Okay, path length, you all know, body moves from O to P and from P to Q. Therefore, path length would be OP plus PQ divided by time interval. Time interval from O to P it takes 20 seconds and from P to Q it takes 5 seconds. Okay, OP plus PQ. What is OP? How much? Forget about the sign because it is distance traveled. Forget about the direction. Sign means you are forgetting about the direction. Okay, so O to P 400 and 400 to 150. Therefore, OP is 400 plus P to Q 100, 200, 250, correct? 100, 200, 250. Okay, this much meter divided by 25 seconds. 400, 600, 650. Okay, 650 divided by 25 meter per second. Okay. So this will be 5 5s are, 5 1s are, 5 3s are. Correct? 5 5s are, 5 1s are 15, 5 3s are. Okay. 5 1s are, 5 2s are 10, 30, 5 6 are. Correct? 5 5s are 25, 5 1s are 5, 15, 5 3s are 0. Okay. Fine. 5 1s are okay. 5 2s are 10, 35 6 are. Okay. So what is this? This is average speed. Average speed is 26 meter per second. Okay, you calculate, okay. Whereas the magnitude of average velocity is 6 meter per second. They are not equal. See, average speed is greater compared to the magnitude of average velocity. Correct? Magnitude of average velocity during the same situation is only 6 meter per second, whereas average speed is 26 meter per second. Correct? So in general, this is the reason why we make a statement like this. In general, average speed is greater compared to the average velocity. In general, average speed is greater compared to the magnitude of average velocity. Okay. As a special case, I can consider the third case like this. The body moves from O to P and back to O. Body moves from O to P and back to O. Body moves from O to P and back to O. See, this is initial position O, this is final position. Initial and final positions are coinciding, therefore x2 is equal to x1, therefore delta x equal to 0. Therefore, average velocity equal to 0. 0 by anything is 0. So, average velocity is 0. But what about average speed? Average speed is path length, that is O to P, OP, and from P to O, that is PO, divided by the time interval. Imagine it takes the same time, O to P 20 seconds and P to O 20 seconds. Therefore, total 40 seconds is required for the whole motion. So, 20 plus 20. OP, O to P, that is 400, plus PO, that is also 400, divided by 40. 400 plus 400, 800, divided by 40. 4 ones are 4 twos, that is 20 meter per second is the magnitude of, sorry, don't say magnitude because it has only magnitude. So, that is average speed. Average speed is 20 meter per second for this case, whereas magnitude of average velocity or average velocity is 0. So, initially as a statement, we mentioned like this: average velocity can be 0, can be negative, or can be positive. So, you might have noticed, because we have considered only a positive direction, you can consider in the negative direction as well. So, imagine this point as R. If you take this point as R, body moves from O to R. Okay. So, body moves from O to R. That's a special case. Body moves from O to R. What is delta x? Delta x is x2 minus x1. What is x2? O to R. R is in the left of O, that is no doubt minus 50. Okay, minus 50 minus x1 is 0. Okay, divided by, say, time. It takes from O to R, it takes, say, 5 seconds. So, therefore 5. So, therefore minus 5 ones are 5 tens are 10 meter per second is the average velocity. Average velocity for the case the body is moving from O to R. So, here average velocity is minus 10 meter per second. It can be negative, it can be 0, or in the previous case, in 2 cases we have observed, in both the cases average velocity was positive. And for this you can as well calculate average speed, that will be always negative, because you are not going to specify the direction there, you are just calculating the path length, that is from O to R, that is 50 meter. 50 divided by 5, you will get the same answer. But forget about the sign in average speed. Average speed always positive. Only in average velocity we are specifying the direction, because it is a vector quantity. Okay, it is a vector quantity. This is all about average velocity and average speed.